Howdy doody. Bill Witte here again with more pre-algebra. Listen, before we begin, I want to remind you what I told you last time. This class that you're taking is basically the bottom floor, the foundation of a 4-story house of cards that we're building towards your degree. It needs to be well established and secure if you're going to go the distance. So I need you to promise right now you're not going to miss any shows, not even one. Okay? And of course you have to do your homework. Now if you have trouble, don't forget you can always go to www.montgomerycollege.edu/prealgebra. Well, okay, what are we going to do today? Oh, exponents. You know, dagnabbit, just when I thought I knew all the 4 operations well, you're going to throw in a 5th one. That's okay, it's not going to be that bad. I'll tell you what, before we do that, let's remember what we did last time, because we're going to need to know this stuff really well, or as I said before, it's going to come back and bite you. Okay? Let's see what we did. Well, the first thing we covered from the very get-go was digits. The ones digit, the tens, the hundreds, the thousands, the 10,000s, the 100,000s. Now what comes after that? The millions and the 10 millions. That's high enough for us for now, okay? And we use those to do a lot of the operations. One of them was rounding. We rounded 267,364, to the nearest 100. Of course, we had to know what digit that was. There she blows. That means that every number after that, or every digit after that, is going to be a 0. So let's see. What's our options here? It's either going to be 267,300 or 267,400. How do you decide? Remember, we use the next digit after the 100.
Perhaps I could be of some assistance.
Which was the 10. And if that was more than halfway up, in this case it is, we throw out the wrong answer, and of course we're going to go up in this case and round up. Okay? Could there be any other problems with rounding? Well, how about this one?
How about a little fire, Scarecrow?
Let's round 765 to the nearest 10. Sounds easy. We know we're going to use the tens digit. Everything after that has to be a 0. So it's either 760 or 770. What do we use to decide? The next digit. In this case,
Houston, we have a problem.
the ones digit. But ouch, 5, I'm thinking, is right in the middle. Remember what we told you last time. If it's 5, you're going to go up. 0, 1, 2, 3, or 4 is down. 5, 6, 7, 8, or 9 is up. Okay, so in that case, you're going to round up. You might also want to round up when you're tipping, especially your teacher. Okay? What else do we have here?
Go!
So the answer in this case is 770.
Who cares?
Well, I'll tell you, rounding and estimating is of great use all the time, especially when it's a problem that you really don't need the exact answer. You just need an estimate. For instance, estimating distances. Let's take a look at this one. We could add all those up to take the trip, or we could round. 94, 379, and 281. Let's do it. Make it an easier problem. 94 rounds to 100. 379, oh, that one's going to go up to 400. Now, how come I chose the hundreds? Because that was the largest digit that they're showing. And the last number, 281, is going to go down. So down to 300. Oh, it's going to go up to 300. So what we're looking at here is about 900. About now, and that's close enough for horseshoes. Okay?
Go!
Especially when you're driving distances, make sure you have enough gas.
Thank you, sir. May I have another?
Well, what about addition? And how did digits come into play there? Well, we just lined up the digits. Do you remember? 763, 162, and just added up basically things that were the same. The ones digits, the tens digits. Uh-oh, that adds up to 12. So we put the 2 and carried the 1 from the 12.
Lighten up, Francis.
Not hard. And now we had to add 1, 7, and 1, and got the next number, 9.
Oakley dokley doo.
And that was the answer. Is that as hard as it gets? Well, let's take a look at one more. How come they have different, if you have a different number of digits, we're still going to line up those digits, the ones with the ones, the tens with the tens, etc. Okay, now 4 and 8 make more than 10. That's 12. So I'll put the 2 and carry the 1, not a problem. Now here we go. 1, 5, and 9 make 15. Am I going to have to do this again? I'm going to put the 5.
Now what am I gonna do?
You carry again. Put the 1. And we add the 1 and the 6, and we got ourselves an answer.
Excellent.
So it's not that bad. That was, we covered addition.
Yes, you're in deep dough now.
What about subtraction? Well, once again, we line up the digits. Line up the ones with the ones and the tens with the tens and all that, and basically just subtract them. 3 minus 2, 6 minus 6, remember, 0 is a number. 7 minus 1, and that's an answer. Not so hard. Any problems we might have with this? You remember your old buddy carrying. Let's take a look at one like that. Once again, we're going to line up the digits. Ones with the ones. Okay, now let's see. 5 minus 8 we can't do, so we're going to have to borrow.
Now what am I gonna do?
We'll borrow from the 4. Of course, that 4 will become a 3, and we'll take 10 and add it to the 5, and we'll have 15. Now we can subtract. 15 minus 8, 7. And 3 minus 2, 1. And there's nothing down there, but we'll sew 6 minus 0.
I'm such a genius.
Subtraction ain't so bad, is it? Okay. What else did we have? Well, we had a whole boatload of properties we covered, and you're going to have to know them all the way through algebra. Okay? Let's go through them real quickly. The multiplication property of 0.
Jolly good.
In English, anything times 0 is going to result in 0. 5 times 0 is 0. X times 0. Still, you don't even know what x is, but x times 0 is still 0. Hookie times 0, still 0. This is easy. Now, what was another property? Oh, the multiplication property of 1.
I say, old
That's very similar, but in this case, anything times 1 equals itself. 5 times 1 is 5. X times 1, I don't even know what x is, but I know x times 1 is x. And times 1 is, let's hear it, you knew that, okay? A couple more properties we covered. The commutative property.
Jolly good.
Remember what that was? That you could switch the order or commute or move the order of things when you're multiplying. 5 times 7 is going to give you the same answer as 7 times 5. 2 times 10 times 3 is going to give me the same answer as 10 times 2 times 3. What happened there? Oh yeah, I switched the 2 and the 10. I'm allowed to do that by the commutative property. Remember, this is pretty special because it only works for multiplication and addition. It doesn't work, as you can see here, for instance, for subtraction. 7 minus 5 isn't the same as 5 minus 7. Doesn't work for division either. 10 divided by 5 isn't the same as 5 divided by 10. Okay, so the commutative property says you can switch the order of this operation, multiplication, and not change the answer. Another property we covered, the associative property. You always mix that up with the commutative property. Now here we're not switching the order. This is when we're dealing with more than 2 factors, or the things that are getting multiplied, and we're not switching the order, we're just associating different ones on either side. In this case, we're associating the 2 and the 10, doing that first. Let's going to give me the same answer as long as I'm multiplying if I associate the 10 and the 3 first. What's changed? Not the order, 2, 10, 3, 2, 10, 3, but where the parentheses are.
What?
So I'm changing the order of the things I'm associating. As you can see, 2 times 10 is 20 times 3, 60. It's going to give me the same answer as 2 times the 30. Okay? Here again, this doesn't work for any other operation besides multiplication and addition. Here we can see that it's not going to work, for instance, for subtraction. 10 minus 7 minus 2 isn't the same as 10 minus 7 minus 2. One's going to give you 3 minus 2, or 1. The other's going to give you 10 minus 5.
No!
It's not going to happen. The associative property only works for multiplication and addition. I think there was one more, and that was kind of a mixture of the two. The distributive property of multiplication over addition.
Jolly good.
Basically, this is the one exception to the order of operations. Remember, the order of operations had us doing what's inside parentheses first. If you're in a situation like this, you can do what's inside parentheses, or you can distribute that 2 to each of the numbers inside parentheses. 2 times 3 plus 2 times 4, and you'll get the same result. 10 times 5 and 10 times 6. You'll still get the same result.
Who cares?
Why would we want to worry about the distributive property?
I can do that, but I don't want to.
We use it when we can't do what's inside parentheses. X plus 5 we can't do at this point, but we can still distribute the 10. 10x and the 10 times the 5.
This is great, man.
So it is a nice little thing to have at your disposal.
And now, ladies and gentlemen, for our next attraction.
Remember multiplication. Okay? There was some carrying there. We take each digit. 2 times a 9, we get 18. I'll put the 8 and I'll carry the 1. Now I go 2 times 8, get 16. And that 1 that I carried, I'll add in and put the result. Okay? Now if I have more than one number on the bottom, I'm going to do what's called partial products. For instance, let's look at this one. Well, we can't multiply by 43s. We're going to take one digit at a time. Let's take the 3 and multiply him first. Hence the term partial products. 3 times 9 is 27. So I put the 7, carry the 2. Now, 3 times 8, 24. Add 2 more. And we get our 26. And we'll put that up. Now, we haven't done the 4 yet. And we'll do him now. Of course, that's not really a 4, that's a 40. So we're going to line it up with the 10s. 4 times 9 is 36. See, note where we are going to put the 6 of the 36 for the 10s group. Okay, and then carry the 3. Okay, now 4 times 8, 32. And 3 more from the carrying gives me my 35. Now I have 2 products, partial products, and I add them up. Let's see, 7 and nothing. 6 and 6 make 12. Carry the 1.
Thank you, sir. May I have another?
All 3 of these give me 8, and the 3, and that's not so bad. Okay, that's partial products. Remember division from last time. We have to know this very well, and the words that I'm using. Typical division problem. 60 divided by 2, we know is 30. What are these things? The thing that's getting divided is the dividend. The guy that's doing the dividing is the divider or divisor, okay? And the answer is the quotient. Can it look any different? Absolutely. A fraction basically is a division problem. Here, 50 is the dividend. He's getting divided. 10's doing it, the divisor. And 5's the quotient, the answer. Of course, remember your old buddy, regular old division, where in this case 42 is the dividend, 7's the divisor, and 6 is the quotient. Now, something about division you're going to have to know. Division, of course, is the opposite operation of multiplication. So you're going to need to know that the definition of division is, take a look, 24 divided by 6 equals 4 only because 4 times 6 equals 24. You'll need to check. Hoo-hoo divided by 3 equals 2. Apparently, 2 times 3 must be hoo-hoo. Okay? That's going to be an important notion to consider when we look at some of these properties of division. You'll need to know them. The first one, the division property of 1, not so hard.
Chop.
Basically, in English, anything divided by 1 equals itself. Well, here the term 1 is the identity element. You end up with the same identity. You can take Clark Kent's glasses off, but he's still the same guy. We know who he is. 5 divided by 1, still 5. X divided by 1, still X. Divided by 1, still he. Okay? What about the first division property of 0? We have 2 for 0. This is the first one. And that is, this one's easy. 0 divided by anything is 0. 0 divided by 5 is 0. 0 divided by 2, still 0. 0 divided by is still 0. You know why? Think about it. Let's go back to our definition of division. 0 divided by 5 is 0 because 0 times 5 equals 0. Because 0 times 2 equals 0. We can check these. Because 0 times equals 0. Okay? So that's the first division property of 0. You'll need to remember it. The next one's the toughest one. The second division property of 0. Well, it's tough. Okay? That's where we flip things around. Anything divided by 0, we don't know the definition of. I'm not kidding. 24 divided by 6 is 4 because 4 times 6 equals 24. Okay? What's 24 divided by 0? Remember? Could it be 24?
Wait a minute.
No, it can't be because 24 times 0 doesn't equal 24.
No way.
Could it be 0?
You're just
Still can't be because 0 times 0 doesn't equal 24.
No way.
In fact, you can't think of anything times 0 that equals 24. So, consequently, anything divided by 0 is undefined. Okay? Okay, what else did we cover for division? Well, actually, computing division, long division. Ooh, most people have trouble with this. Let's do a problem, or at least discuss what we're going to do in a problem. Remember when we did long division, we made an estimate of our answer, then we actually checked it out. We multiplied, we subtracted to see what we were off by, and we brought down the next digit to make a more closer estimate. Okay? Well, guess what? We went back after we did those 4 steps and we went through them all over again. Estimated an even more closer quotient, remultiplied, subtracted again to see, hopefully I was closer, okay, and bring down the next digit again, if there is one, okay. Now we keep doing that until there isn't one and you got yourself an answer. Okay? Well, don't forget averages too, okay? I'm going to give you a division problem in this slide. Averages, for instance, in this example, the average is the sum of all your numbers divided by how many numbers you have there, okay? In this case, we've got an example of someone who bought textbooks for 39, 65, 48, 28, and 45, and he's wondering what his average is. Well, let's add them up. Line them up, of course, to add them up. Okay? The ones, let's see, what do all those babies add up to? 35. So put the 5, carry the 3, and then add up the 10s, and I got 225. Not done yet, am I? I'm going to take that 225. How many values do I have here? 5. And I'm going to divide that number by how many values? By the 5. Let's look at division. Let's see, make an estimate. 5 into the first number goes nonce. Well, 5 into 22, we make an estimate. Goes 4 times. Remember the next step? Multiply, 4 times 5. Third step, subtract. Let's see what we're off by. Off by 2. And the fourth step is to bring down the next digit, if there is one. Okay, now we go through those same 4 steps again. 5 into 25, I make a guess. 5 goes in exactly this time. Multiply and subtract to see what I'm off by. Good, I'm not off by any. And I bring down the next digit. Well, there isn't a next digit, so there's your long division.
Great horny toady.
And that's the average, and that's what I said last time I was at the bookstore. That's about the average cost. Okay, let's get to the new stuff. Here we go for today. What were we going to cover again?
Excuse me, Professor Brainiac.
Oh yeah, exponents. Ooh, what the heck are exponents? Well, consider if you would, they smell a lot like multiplication. Remember what multiplication is? 5 times 3, for instance. Basically, multiplication is multiple addition. See what's going on here? 5 times 3, there's 3 5s. That's what multiplication really is, multiple addition. Well, exponentiation isn't multiple addition. Exponentiation is multiple multiplication. Here we're doing the same thing. There's 3 of them. Okay? We get a much bigger answer. Well, that's the idea of exponents. Let's look at a couple examples. 3 to the 4th power, very similar than the last problem. It's going to be multiple multiplication. 3 times 3 times 3 times 3, 4 times. Note, multiple multiplication. Got an answer, 81. Let's look at another one. 2 to the 5th power. Ooh, there's a whole boatload of those babies. 2 times 2 times 2 times 2 times 2, 5 times. Multiple multiplication. Can you do that one in your head? That's 4 times 2 is 8, times 2 is 16, times 2 is not so bad. Nice small number. Let's look at another one. We're going to get this down. Okay? 5 to the 3rd power. You're getting the idea. There's 3 of them, and they're all multiplied. 5 times 5. Of course, we can't do more than 2 things at a time, so we only do 2. Get an answer of 25. 25 times 5. Ooh, that's a tough one. It's 125. Okay? Let's look at another. See if we can make generalizations here.
I have a feeling some bad stuff is about to go down.
No. It's the same stuff. Okay, relax, Francis. 4 to the 2th, or 4 to the 2nd power, times 1 to the 4th. What does that mean? Well, let's see. 4 to the 2th means I'm multiplying 2 4s, and I'm going to take that answer and multiply it times 4 1s. Okay? 4 times 4 is 16, and we know our multiplication property of 1. You can throw in as many 1s as you want. You're still going to get the same answer, 16. Easy sleazy.
Wait a minute.
Wonder what 1 looks like when it is an exponent. It's so simple that it's hard. Take a look at this one. 5.
Now what am I gonna do?
Well, relax. That means you're going to multiply 5 times itself one time. That's it. Bam! That's the answer. Only one of them. That's all you got to do. So 1 can be an exponent too.
Pay attention, son. This is for your own good.
Okay, now we've covered the 4 basic operations: addition, subtraction, multiplication, and addition, and exponents. Okay? We're going to mix them all up now, but let's get the words right. Okay? Consider what I'm talking about when I say, for instance, operators. Let's take a look. Operators are, as I said, one of those 5 things: multiplication, addition or subtraction, division, exponentiation, things that operate. There's your operators. What are the other things in here? Okay, we're going to call those terms. Those are the things, if you would, that are getting acted upon by the operators. Okay, we're going to need to know those words, operators and terms.
Yoink.
Well, it's going to matter here. Let's take a look at this problem. 5 plus 7 times 10. Could we go 5 plus 7, get 12, multiply by 10? Seems reasonable. The answer could be 120. I got a problem here for you. What if we took the same problem and instead of adding the 5 and the 7, we decided to do the 7 and the 10 first? I get a completely different answer, don't I?
Yes, you're in deep dough now.
What am I going to do? It matters which operator I do first. I'll get a completely different answer depending on which one I do. So, you're going to have to know what we call and memorize the order of operations. I mean, memorize it. All of algebra is going to be based on the order of operations. It's going to be the answer to just about every question you have next semester. What is the order of operations? Well, we're always going to do what's in parentheses first, then do any exponents in the problem, then any multiplication and division. Now, if we have more than one multiplication and division, we're not going to automatically do the multiplication then the division. We're going to work our way through the problem left to right and do all the multiplications and divisions. And after we've done all those, then and only then we'll do the additions and subtractions. Once again, if I have more than one of them, I'll do the leftmost one before I'll do, that's kind of the second tiebreaker. And I always say the last thing is if there's a fraction, you simplify it. That's the last thing we'll do. Let's go back to our problem that we didn't know what the answer was going to be. Are we going to add the 5 and the 7 using your order of operations and then multiply by 10? Or are we going to multiply the 7 and the 10 first and then add the 5? Well, the order of operations, you're going to have to memorize it, tells me to do all multiplications before any additions. So the answer in this case is certainly and only 75. In this case, we're going to do the 7 times the 10 first, get the 70, then and only then add the 5 and get my answer as 75.
Darn tootin'.
That's the way we do it. Let's look at an order of operations example. Okay, now what are we supposed to do here? Well, we go through the order. We have to do parentheses. Well, we don't have any parentheses. But the next step is exponents. We don't have any of those. Okay, you don't always have things. Okay, what's the next step? Multiplication and division. Well, we're going to do all those first. We do our 12 times our 5 and get 60, and then we do our 3 times our 6 and get 18. Notice we saved the addition until after the multiplication. And that's your answer. And that's the only answer. Okay?
Thank you, sir. May I have another?
Absolutely. This is not easy, but you do have to know it very well. Ooh, look at that bad boy. Well, let's see. We're going to do, we've got to memorize this. Do what's in parentheses first. What's in parentheses? I see the 8 minus 5. So that'll result in 3. Nothing else has changed here. Okay, now we've done what's inside parentheses. What's after that? Exponents. Ooh, there's a 4 to the tooth. I'll do that. Nothing else. That 4 to the tooth power is 4 times 4, or 16. Okay, now, next thing to do is the multiplication. That was a 6 times 3 and gave me the 18. Okay, I've done all that. I don't have any division. So my next step is all the additions and subtractions. Well, let's do the additions. 2 plus 18 is 20, and 16 minus 6 is 10. And we've done that step. Now the last step, I always say in the order of operations, is to reduce any fraction. Remember, a fraction is basically a division problem. So 20 divided by 10 is 2.
Dad, I'm such a genius.
It wasn't so bad, but you have to follow that order. Don't be sucked into the, I'm just going to go from left to right. I'll do it however I want. You'll get an answer, but it'll be the wrong answer, Buford. Okay? Remember, relative to exponents, finding the area of something. How did we find the area? Basically, we counted the squares. Remember that? In this case, it was 15, we'll say, square feet. Okay, that's the area of this thing. Well, there was another formula that we could do to find the area of something, and that was to multiply the length times the width, rather than going through all that counting. Remember that?
Ooh, I'm dying!
We used it when we didn't feel like going through all the counting. Okay, well, let's see. In this case, the length is 9 and the width is 7. Ooh, I wouldn't want to do all that counting. I can just multiply, use the formula, length times width.
Hello. 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 Hello.
That's the area of a rectangle, length times width. Get a nice easy answer of 63. 63 squares in that picture. We're going to say square inches because they gave us a measurement of inches there. Okay? Well, the reason I wanted to remind you of that, relative to exponents, let's look at this next problem.
Wait a minute, 99. That gives me an idea.
If you consider that a square is a rectangle, where all the sides are equal, we're going to use that length times width formula. Of course, we could, if we wanted to know the area, just count the squares in this bad boy, or use length times width, 3 times 3, and get an area, length times width, in this case, of 9 square feet.
Cool.
But we could also say that since the sides are the same, that area is side times side, or side, here's where the term comes from, side squared. Okay? See, to the 2th power is basically multiplying something times itself. That's where we get 9 square feet.
Uh-oh.
Well, this one basically is a rectangle, but it's also a square. It's a rectangle with equal sides. So we really only need to know one of the sides.
Go!
In this case, they're telling me it's 7 inches. I don't even have to know the other thing, because I know in the area of a square, a special type of rectangle, mind you, the area is side squared, or side times itself. And in this case, 7 squared, or 7 times 7, is 49. Pretty cool, huh, Buford?
Captain, we can't do it. If we keep this speed, we'll blow up any minute now.
Oh, come on, we can hang in there. We can do this, okay? We're just going to do it with letters, okay? We're going to do that order of operations with algebraic expressions. Let's try it.
This is a pickle, George. This is a pickle.
No, it's not. Remember, we're going to have to know that order of operations. Let's remember it again.
The great Oz has spoken.
Parentheses, do all those first, then exponents, then multiplication and division, work your way left to right amongst those, then addition and subtraction, work your way left to right amongst those, and then last but not least, if you have a fraction, we'll simplify that. Okay, now you remember that, and let's take a look at this problem. In algebra, we use letters as placeholders for numbers. So they're going to be numbers eventually, so they have to follow all the rules of numbers. The order of operations is certainly one of the most important of those rules. Let's see if we can calculate this expression by putting in numbers for these letters. Well, let's see. I'm going to put in, instead of an A, I'm going to tell you to put in, I just pulled it out of my head, I'm going to tell you to put in a 4, and instead of the B, we're going to put in a 3. We have to follow the order of operations now, okay? So there we go. We have a 4 instead of the A, and a 3 instead of the B. Now we have to follow the order of operations. What's the first step in the order of operations? That's to do what's in parentheses. Well, the only thing I see in parentheses is the 2 times the 4, so let's do that. 2 times 4 is 8. Okay, now we do our exponents. I see 8 being squared. That's an exponent. That'll be 64. And I see 2 3s over there. Okay, now that little 2 only has power over the 2 that's in the 2 only has power over the 3 that's in parentheses. Why is that? Because you do what first? You do your exponentiation before you do your multiplication, before you multiply those 3s. Okay, so we have to do exponentiation before multiplication. So in this case, the 8 squared is going to be 64, and the 3 squared is going to be 9. Now, and only now, do we do the multiplication of the 3 and the 9, you see, by following the order of operations. And I get 27. And lastly, in this case, we do the subtraction and get an answer. Thank you.
Do that again.
Okay, we'll do another one. We have a new expression with new numbers for letters. Okay? And this time we have x's and y's. It really doesn't matter what the letters are. Now in this case, note we have 2 y's. Okay?
Holy heart failure!
Relax, Francis. If I decide to put a 7 in for the x and a 3 in for the y, which y? Well, both y's you're going to put a 3 in. Any place you see a y, you're going to put a 3 in this case. Let's do it. I see the 7 squared, and you see the 3 instead of either of those y's. Now, I don't have any operations to do inside a parenthesis, so I can skip that first step. I do have some exponentiation to do. Make sure that you do it before the multiplication. For instance, before multiplying that 2 and that 3. 7 squared is going to be 49, and the 3 squared is going to be 9. Okay? Now I've done my exponentiation. What's the next step? Multiplication. Okay, I see a 2 and a 9. Okay, and that gives me 18. Now I have some addition and subtraction. Which do I do first? Because they're kind of on the same step. Well, here is when you have more than one, you are in fact going to work left to right. 49 minus 18 is 31, and then, and only then, do I do my addition and get 34. This is a tough problem, okay? But you know what? We're going to do it all over again because these are variables. Why would they be called variables? Because guess what they do? They vary, okay? This time, I'm going to take the same expression. We're going to take the same expression and we're going to substitute in, instead of x this time, we're going to put in a 5, and instead of y, we're going to put a 2. See where we put in the 2 for either one? Okay? Well, let's see. Once again, follow through your order of operations. Do all your parentheses. We don't have anything inside parentheses, so we go right to exponents. 5 squared is 25. The 2 squared is 4. Okay, I'm done with all my exponents. Now I do my multiplication. 2 times 4. Well, it was tempting to do some of that addition and subtraction, wasn't it? Okay, and now I do my subtraction, get 17, and then my addition, in this case working left to right. It's getting easier, huh? What do you think? Okay. Now, the next step is for you to come up with which operator to put when solving a word problem. We're not going to get just to the word problems yet, but you need to know which operators to put in each time. Okay? Well, various words are going to lead to various expressions or various operators. Let's take a look, for instance, at words that suggest addition in a problem. When they say the sum, S-U-M, sum of A and B, you know what that means? Yes! It means A plus B. It infers addition.
Survey said.
More than, 8 more than X, means to take X and add 8 to it.
Ooh, yes.
So that infers addition also, more than. How about total? The word total of anything, that's usually going to be more than 2, means yes! Add them all up. Okay?
Survey said.
And maybe increased by, here's another word. These are all words that lead to addition. Y increased by 3 is going to be Y plus 3. I'm thinking you already knew that, but I wanted to say it. Okay? Well, those are the words for addition. What about the ones for subtraction?
Bring it on.
We can do it. Let's take a look. Of course, A subtracted from B would seem easy. Don't, be careful here. A subtracted from B. Even though they said A, what are you starting with in this problem? You're starting with a B, and you're taking A away from it. So guess what this one's going to end up being? I might be surprised. It's going to be B minus A. A subtracted from B. You have to be careful in that case. 8 less than x. The words less than, okay, means to take x, start with x, and get 8 smaller. So we're going to go x minus 8. Less than is going to be another one that infers subtraction. The word difference is probably the most common of all. The difference of y and c means y minus c. For instance, the difference of 5 and 2, you know the difference between 5 and 2 is 3. Because in your head, what did you really do? You went 5 minus 3. Or decreased by. There's another set. Z decreased by 3 would be z minus 3. Okay, those are the words for subtraction. Let's look at some of the words for multiplication.
Introducing.
The word product infers, you're going to have to know that. You might not have known it before. The word product infers multiplication, just like sum infers addition. So the product of A and B means, that's right, A times B. Of, we're going to have all the time. 8 of x's, okay? 8 of x means 8 times x. Of is the same as times. We're going to use that very often in the future. Twice, well, that's a fancy, that's a little bit more specific. Twice z, of course, is 2 times z. And of course, the word times makes it easy. Y times 3. It's just, you're going to write multiplication, okay? Leaves us with one more obvious one to do, and that's division. Let's see, what are the words that infer division?
Now what am I gonna do?
We knew from before, quotient. Isn't quotient the answer to a division problem? So the quotient of A and B means A divided by B.
I can do that, but I don't want to.
8 into x means they want you to divide. But what did you start with? You started with x, and you took 8 into it. So this is going to be one of those flippers. X divided by 8, or x over 8. Okay? Of course, that's an easy one. The words divided by, y divided by 3, simply y over 3, or y divided by 3. Remember that a fraction is really a division problem. Okay, that's all for today. Let's do some review of what we've covered today. Okay, what did we cover again? Well, the idea of exponents. Remember that? Exponentiation is really multiple multiplication. For instance, 5 to the third power, not 5 times 3, 5 to the third power is 5 times 5 times 5, 3 times. Of course, we can only do 2 at a time. So we get an answer, 5 times 5, 25, and then take that result and multiply it times the next one and get, in this case, 125. What if we change it on you? 3 to the fourth power. Let's see, multiple multiplication. 3 times 3 times 3 times 3. Once again, we can only do 2 at a time. So I'll get 9. Take that result and multiply it times 3 and get 27. Take that result, probably get a calculator out, multiply that times 3 and get 81. Let's look at another one. 2 to the, 2's a low number, I can do a high one. 5, okay, 2 to the fifth power means, don't even think about 10, right? 2 to the fifth power means 2 multiplied by itself 5 times. That's going to be 2 times 2 times 2 times 2 times 2. Okay, let's see, only 2 at a time. 2 times 2 is 4, times 2 is 8. 8 times 2 is 16. Take the result, 16 times 2 is 32. Hooty doody. Okay?
Wait a minute.
Well, remember, this one is so easy it's hard. 1 as an exponent means...
Now what am I gonna do?
1's a number, give it a break. Means you're just going to put one number, 5, and that's the answer. It can happen. Okay, so don't be afraid of that. Okay, We had a lot of vocabulary today.
Pay attention, son. This is for your own good.
The idea of operators and terms. The operators were the things that were doing the action, addition, subtraction, multiplication, division signs. Operators, okay? The things getting acted upon were the terms. Okay? We remember that we're going to have to memorize for the rest of your life in math the order of operations. Okay? Some people like to remember parentheses, exponents, multiplication, division, addition, subtraction. Please excuse my dear Aunt Sally. Some people like to remember that. It's one way to do it. Okay? Let's remember what they are again, the order of operations. Parentheses. What's after parentheses? Then you do exponents. Then you do multiplication and division. Remember, if we have more than one, we're going to work from left to right within the multiplications and divisions. Then we do any additions and subtractions. Boy, that was way down the line, wasn't it? You know, I got to tell you, addition and subtraction, a lot of students like to do that first because it's the easiest. And isn't that weird that here you're going to end up doing that last? Well, almost last, because what's the real last one? Is to simplify any fraction. Let's look at some examples of this to remind ourselves of how we did that. Okay? In this problem, for instance, we would go through, we don't always use all the order of operations. What I mean is, in this case, the first step is parentheses, there are none. The next step is exponents, there are none. The next step is multiplication. Now I have two multiplications. I got the 12 times the 5 and the 3 times the 6, and I'll do both of them. Actually, I did the 12 times the 5 first and got 60, and then the 3 times the 6 and got 18. Okay, once I was through all my multiplications or divisions, I went through addition, and that was the answer in this case. Okay? They get harder.
Thank you, sir. May I have another?
Absolutely. Wouldn't want to throw a hard one on the test without giving an example here. Okay, let's see. We have to do what's in parentheses first. That's the 8 minus the 5, and that'll result in 3. I haven't done anything else yet. Okay? Parentheses. Exponents. Excuse. Okay? Any exponents? There sure is. 4 to the 2th power is 16. Haven't done anything other than that. Okay, parentheses, exponents. What's next? Multiplication. 6 times 3. 18. You have to do that next. Okay? I've done my parentheses, my exponents, my multiplication and divisions. Now the additions and subtractions. 2 plus 18 is 20, and 16 minus 6 is 10. Okay, I'm almost home. Now I'll simplify the fraction. 20 divided by 10 is 2.
Dad, I'm such a genius.
Okay, now you're really going to have to discipline yourself a lot of times in these problems, not just to do whatever order you feel like or whatever the easiest one is. You've got to go through the order of operations that you've memorized, okay? And you won't know whether you're wrong or not if you go through another order. You've got to go through that order of operations, because if you don't go through it, you'll get an answer. It won't be the right answer, though, okay? Okay. Let's do the same stuff, order of operations, with variables, with letters, okay? Remember, letters represent numbers, okay? In this case, you may remember that we replaced A with a 4 and B with a 3. And there they are. We still follow the same order of operations. Do what's in parentheses first. There's the 2 and the 4, multiply. That's all we're going to do, and get 8. Okay? Now we'll do our exponents, and we've got a couple of them. 8 to the 2th power and 3 to the 2th power. Okay? We'll only do those exponents in the next step. 8 to the 2th power is 64, and 3 to the 2th power is 9. Okay, we've taken through that step. Now, we do our multiplication. Do I have any multiplication? There's a 3 times 9. And lastly, our subtraction. Okay?
Do that again.
We'll do it. This time we have different letters.
Holy heart failure!
And different numbers. We're going to replace every occurrence of x with a 7 and every occurrence of y with a 3. as you can see, every occurrence of x with a 7 and every occurrence of y with a 3. Okay, let's see. Let's follow that order of operations. Parentheses, well, there really isn't anything to do inside. Even though there is something in parentheses, there isn't anything to operate, if you would, or perform inside parentheses. So we're done with that part. Now exponents. So we've got some exponents to work on. 7 to the 2th we've got to do. That's 49. And 3 to the 2th, which is 9. Okay? Okay, we've done that. What's after parentheses, then exponents, then multiplication? I see some multiplication there. 2 times 9. That's 18. Now I've got some addition and subtraction. Which do I do first? I've got both. This is the time when they're on the same level. You're going to work from left to right. 49 minus 18 is 31. And then and only then do you do the next one, the addition, and get 34. Now interestingly enough, remember that variables are called variables because they vary. They can change. Okay? So let's take the same expression and put in different numbers.
You never know what you're going to get.
Well, you can put in different numbers and you may get, and probably will get, a different answer. In this case, we're going to take the same expression and replace every occurrence of x with a 5 and every occurrence of y with a 2. See? Every occurrence of x with a 5 and every occurrence of y, in this case, with a 2. Now we'll follow through our order of operations. I don't have any operations to do inside parentheses, so I'll go right to my exponents. What do I have here? 5 to the 2th power, that's 5 times 5 is 25. And the 2 to the 2th power, 2 times 2 is 4. There we go. Now, parentheses, exponents, multiplication. There's 2 times 4 is 8. And now, once again, my addition and subtraction from left to right. 25 minus 8 is 17. Then adding in the 2, I get 19. And that's my answer. Okay? I'm not going to give you anything much harder than that. Okay, what else did we cover today?
Wait a minute, 99. That gives me an idea.
Oh, yeah. We covered length times width, but with squares. Well, remember that a square is really a rectangle where the sides are the same. In this case, you knew this same, so I didn't have to write 3 twice. Okay, and remember that area is how many squares is inside something. So we could calculate this. We could calculate by going length times width. But since it's a square, we're going to go, since the length is the same as the width, we could go length times length, or width times width, or we're going to call it, in this case, side times side.
Cool.
Or side, for you Einsteins, side squared. In this case, 3 squared is 9. Now you can see that there's 9 squares, but you can also see that the formula works there. The formula is going to be of more use when we have a little bit, perhaps larger square that we have to find the area of. In this case, I don't have to count them all. In fact, I don't even have to know both sides. I have to know that it's a square, and I can measure each side knowing that both sides are 7. So I can use that formula, side squared, and 7 squared in this case is going to be 49, and since it was inches, it's 49 square inches, or 49 inches squared. Okay? That's a little different variation on the formula for a rectangle. We talked a little bit about translating phrases into expressions. For instance, the words that infer addition. The sum of A and B is the addition of A and B, or A plus B.
Survey said.
Look for the word more than. That infers addition.
Ooh, yes.
How about total? When you see total, it doesn't always be, it's not always going to be 3 things. It could be 4, 5, 6 things. One thing's for sure, it's going to be them added up, and it infers addition.
Survey said.
And increased by is another phrase that infers addition.
Yes.
Okay? Remember subtraction.
Bring it on.
A subtracted from B, this was the tricky one, You started with which letter? A subtracted from B. You started with B, so this one's going to be B minus A. 8 less than X. We started with, you got to always ask yourself, especially with subtraction, which one you started with. You started with X. 8 less than that. Okay, so we're going to write X first in this case. So it's going to be X minus 8. The word difference infers subtraction. Okay, and you keep the same order. And decreased by infers subtraction. Get used to that. Okay, how about multiplication? Remember that?
Introducing.
The phrases that infer multiplication, certainly the word product is a weird one for you. The product is the answer for a multiplication problem. So the product of A and B is A times B. The word of infers multiplication. So 8 of X is 8 times X. Twice, well, of course, infers 2, or 2 times Z. And times, obviously, infers multiplication. Last one, let's look at the words, or remember our words for division.
Now what am I gonna do?
Remember the word quotient infers the answer to a division problem. So the quotient of A and B is A divided by B.
I can do that, but I don't want to.
8 into X means 8 divided into X means I started with X in this case. So this is a little tricky. You're going to have to go X divided by 8. You have to switch them. You got to be careful there. Sometimes they switch. This one's an easy one. Y divided by 3. And of course, ooh, that's enough for today. I got to tell you, it's time to go out and do your homework. Okay? Which you must do. I'm going to ask you not to try to study your homework or watch things. The way that you practice this is to do it. Actually, take that pencil in your hand and do the homework. Okay? Don't be dreaming, thinking that you're just going to be able to study and it's automatically going to get absorbed into your head. Remember that if you have any trouble with the homework, you can go to our homepage at www.montgomerycollege.edu/prealgebra, or you can email me at bwitte@mc.cc.md.us. Till next time, thank you for listening. Thank you very much.